Good morning. This is the beginning of Unit 4B. It's going to be starting off with solving radical equations. We're going to be doing graphing radicals, graphing piecewise functions, graphing absolute value functions. But today this is the only topic. Equations with radicals. We're just going to limit this to square root and cube root. And it's basic algebra. The one thing is that you just have to know the inverse. The inverse of square root is squared. The inverse of cube root is cubed. So we're going to use that power rule to eliminate the radical and then solve. So here are the steps. Step 1, isolate the radical. By the way, this is page 62 in my notebook. Get the radical alone on one side of the equation. Apply the power rule, which is raising both sides of the equation to whatever that radical is. For a square root, you would square it. For a cube root, you would cube it. And then you're going to solve the equation that you have left. And sometimes you still have a radical, not often, but sometimes you do it, and then you would do it again. And one of the important steps is actually to check your solution in the original equation, because sometimes you have an extraneous solution, which is you did the math correctly and you got an answer, but when you substitute it back in, it doesn't make sense, or it's not true. So let's see, example, first one. There's two on the sheet in your notes, and this one I wrote in the red. This is kind of an important one too. I want to go over that one third. But this first example, isolate the radical. So I need to get the square root of x minus 3 by itself, and I do that by subtracting 2. So the x minus 3 is alone under the radical on one side of the equation. 0 plus negative 2 is negative 2. Apply the power rule or square both sides. On the left-hand side, square and square root cancel each other out, so I'm left with x minus 3. On the right-hand side, when you square negative 2, you get positive 4. To get x by itself, you add 3. And there's my answer, x equals 7. So I'm going to substitute this back into the original equation just to make sure that it's valid. So square root of x minus 3 would become square root of 7 minus 3 plus 2 on the outside of the radical, and does that equal 0? Square root of 7 minus 3 is the square root of 4. The square root of 4 is 2. Does 2 plus 2 equal 0? No. So although you solve and you get 7 when you substitute back in, it's nonsense. So this is going to be an extraneous solution. So I'm going to move on down to the next example in your notes. This is a cube root function. So you want to get the radical alone, so you do that here by subtracting 1 from both sides of the equation. On the left-hand side, you're left with the cubed root of 2x minus 4. On the right-hand side, that turns into negative 3. So apply the power rule, or cube both sides of the equation. On the left-hand side, the cube and cube root cancel each other out. You're left with 2x minus 4. On the right-hand side, when you cube negative 3, you get negative 27. Add 4 to both sides of the equation to get x alone. Negative 27 plus 4 is negative 23. Divide by 2, and x equals negative 23 over 2. So I'm going to substitute that back in and see what happens. The cube root of 2 times negative 23 over 2 minus 4 plus 1. I'm only going to deal with the left-hand side of this equation. The 2's cancel out, so I'm left with the cube root of negative 23 minus 4 with a plus 1 on the outside of the radical. Negative 23 minus 4 becomes negative 27. Cube root of negative 27 is negative 3 plus 1, so I get negative 2, and that does equal what's on the other side of the equal sign. So negative 23 over 2 is a valid solution. Now this third and final example I want to show you, this this is going to be an example where you actually have to solve a quadratic somehow to get the solutions. Let's see if I can erase this. Almost there. All right, so I'm gonna, I don't know if I can move this up. So you already have the radical isolated on one side of the equal sign. So you're gonna apply the power rule, square both sides, and I'm gonna move my answer over here. On the left-hand side, when I square a square root, that cancels out, so I'm left with x plus 10. On the right-hand side, when I square x minus 2, I'm multiplying x minus 2 times x minus 2, which becomes x squared minus 4x plus 4. Get everything alone on one side of the equal sign. I would do that by subtracting x and subtracting 10. So this turns into 0. I'm left with x squared minus 5x minus 6. I'm going to factor this, looking for numbers that multiply to negative 6 and add to negative 5. And it's not 2 and 3, it is negative 6 and positive 1. Set each factor equal to 0 and solve, and I get positive 6 and negative 1. And I'll leave it up to you to check to see if either or both of these is a valid solution. See you on Tuesday.